So those traditional technologies are used for collecting the data, and this data is not sufficient for these new emerging technologies of artificial intelligence or real-time data collecting technologies. So that is why it is very essential to see the scope of geospatial technologies in planning, in managing, in installation, in maintaining the farm drainage systems. So that is why this today's topic I have put into this training program, so that I will also learn from various sources and also will be able to deliver some information for your use. So let us see what is meant by geospatial technology. Geospatial technology, as it says, geo means earth and spatial means the information that varies over the space or over the surface of the earth. That is called a geospatial technologies. So the geospatial information is generally referred by the location, and this location can be addressed with the help of longitude and latitude, or address, or city, or pin code. So this is how the locational information is addressed. And when this locational information is used, analyzed, and derived as a data set by the technology, like GPS or GIS or remote sensing, those technologies are called as geospatial technology. One example of geospatial technology is here. It is a Google map. We use it every day when we travel from one place to another place and we don't know the route. So we start this app, Google Map, right? So you can see on this map that there is the location given. This is my location, okay? So the geographical coordinates of this location can be seen on top of this 18.53 north and 73.84 east. That is my location. So this location has a geographical address, and that is nothing but longitude and latitude. So that is my accurate location. But I also have a relative location. Relative location means in reference to other places. There is a NCC headquarters, you can see Sakhar Sankul, Dalvi Hospital, there are roads. So in reference to these roads where I am sitting, that relative location is also seen from this map. So maps generally represent the geospatial information. And this geospatial information is very, very essential in planning the drainage systems. So these are a few technologies which are used from last 1 or 2 decades. Remote sensing, geographic information system, in short it is called as GIS. Then global positioning system, in short it is called as GPS. So remote sensing is, it depends which platform is used for collecting the information. If it is a satellite platform used for collecting the information, it is called as satellite remote sensing. But nowadays you must have heard that even drones have those hyperspectral cameras mounted on them. So drones can also give you the remote sensing information. So it is just a camera which takes the snaps of the Earth's surface, and we analyze that information or analyze that imagery and gather the information that we require for planning. Whether that camera is mounted on satellite, whether that camera is mounted on an aircraft, or whether that camera is mounted on a drone, or it is mounted on a person, maybe it is a handheld camera, it doesn't matter, because that camera is taking the remote images without coming in touch with that particular object or with that particular surface. That camera is remotely collecting the information, so it is called as remote sensing. Okay, and then geographic information system. This is a software system which has various abilities. The statistical analysis of the geographical information can be very easily done in this GIS software. Also, it uses, you can say, interpolation technologies or techniques like kriging or isometric. These statistical interpolation techniques are embedded as spatial analyst module or as a 3D analyst module in geographic information system. It also has ability to store the geo-referred information in the form of map, and it also has ability to combine the different layers or different information that are available in the maps by using an overlay technique. So geographic information system is actually a software which prepares a map containing various informations, various type of informations. So it is also very useful in drainage system planning. Then global positioning system, this is a handheld device which is called a GPS. We also have GPS on our smartphones, and you must have used GPS for determining your location. So we will learn about these technologies one by one. So let us come back to again planning of the drainage system. So these are the generally the typical steps that are used for planning the drainage system. The first step is to conduct a survey and identify the evidence whether there is need of drainage in that farm or in that area or not. So what would be the evidence? So one will have to look whether there is erosion, means a lot of water is coming inside the farm, whether there are wet spots, swells, ponding, or whether there are crops which are showing low yield because of the ponding or waterlogging. So that gives you evidence that a drainage system is needed in that farm. So one has to go into the farm and see everything, and then only that person will get evidence that a drainage system is needed. The same thing can be done by the technology called as remote sensing. As I told you, a drone can just fly over the farm and collect the information or collect the photograph of that farm, from which you can analyze that whether there is ponding or swells or wet spots. So this type of traditional technology which people were using earlier, in that technology, these were the steps. Second step is to conduct the physical survey to obtain and analyze a topographic map. Because you must have learned during the session of design of surface and subsurface drainage that these drain lines, they require a particular slope. And the outlet of the drainage system should be at the lowest point into that farm. It should be delivering water into a drainage ditch. So the slope is, or topography of that farm is very, very important. And physical surveys were conducted earlier or even traditionally to collect the information about the topography of that farm. And you must have heard about automatic levels or dumpy levels. You must have heard about traversing technique to collect the levels of the farm. So those techniques are used for the physical surveys, and the possible location of surface and subsurface drainage outlets are determined. Control points are determined from where the sub-irrigation can be started. The grades of the lines, the main line, the collector drain, the laterals, the grade of all these lines was determined by using the physical surveys. The next step is, after getting the topographical information, then design the surface drainage infrastructure, means what should be the layout of the drainage system, then what should be the length of main, what should be the length of lateral, what should be the length of the collector drain. So all these things come after the topographical survey. So design of surface drainage system first, and then design of subsurface drainage system. These were the typical steps that are used for planning the drainage system. Now let us see the design steps for surface drainage. So you will see here that the first step is to determine the drainage coefficient, that how much water should be removed from the farm within a given time. So that is nothing but the drainage coefficient. How this drainage coefficient is determined? So it is again based upon the topology of that farm. It needs the topological data for calculating the drainage coefficient of that farm. Also determining size, shape, slope, depth, spacing of ditches, and also planning the layout of surface ditches. All these steps, they require the topographical information. Same is like for subsurface drainage systems. We require discharge capacity, which is again based upon the soil type, based upon the land use, land cover, based upon the elevation difference, based upon the topology of that farm. So topology is very, very essential. So the common steps are given here. I have combined the various steps required for the design and planning. So you can see that everywhere we require the topographic information, and collecting this information by traditional methods is very tedious and time consuming. Let us first understand what is topography. Topography is the study of land surface. So which features are available on that particular land? What is the location of that feature? What is the shape of that feature? What is the length of that feature? What is the area or volume of that feature? That information about the land surface is called as topography. For example, if there is a nala or a drainage ditch, so what is the length of that ditch? What is the width of that ditch? That is called as the topography of that particular earth surface. So geographic coordinates of the locations of various features like rivers, lakes, buildings, or farms, and also their elevation, relative elevation, is the distinguishing factor for the topographic maps. And we are suggesting that the emerging geospatial technologies can collect this data for the person who is designing the drainage system. So you can see that this is a contour map, and this is the 3D surface created by using the elevation data of the contour map. So this is created in GIS, and this is a contour map which is prepared by using a traditional survey. So the traditional way of measuring elevation and generating topography are given here. Automatic level, total survey station, laser surveying. These methods are used to collect the relative elevation of various features that are available on the Earth's surface. Probably many of you have already done this traversing survey during which you have collected the relative elevation. So a base point is fixed, and some datum is fixed, and for which some elevation is considered, like 100 is a benchmark. Benchmark is considered, and in relation to that benchmark, the levels of all the objects, suppose there is an irrigation well. So what is the level of that irrigation well? What is the level of the particular farm in relation to the benchmark? That is measured by using these traditional equipments. And the person has to go from point to point, like from here to here, he has to take 2 observations. Then again on next level, he will take 2 observations. So for the entire day, the person has to move with his automatic level or total survey station and collect the relative elevations. After the data of relative elevation is obtained for a particular area, then the statistical tools like Surface Pro or Surface, which use statistical methods of interpolation like kriging or isometric method. So that data was fed to these statistical tools so as to generate the earth surface or topographic surface. And this surface was used then for planning the irrigation system or for planning the drainage systems. So this is how the data was analyzed. Then you can see here, this map that you see on the right side of the slide is the topo sheet. So Survey of India is the agency which is the very important agency in surveying field, and it is a government agency, and it has collected the topographic data through aerial photography. And through aerial photography, it has prepared the cadastral maps, and these maps, they are called as topo sheets, Survey of India topo sheets. On these topo sheets, you will get information cadastral information, roads, rivers, villages, everything. And plus, in addition to that, it also gives you the information about terrain, like contour levels. You will find contours. You will find some datum points that are given by the Survey of India. So this topo sheet is also useful in planning the drainage systems on a larger area. The resolution of these topo sheets is 15 seconds by 15 seconds. So it is quite a good resolution. And these contours, if they are fed into a GIS software, you will be able to prepare a topographic map. Or if these contours are fed into any statistical tool like Surface Pro or Surfer, it is possible to generate the topological map of that particular area. So these are the traditional ways by which people used to prepare the topological map for planning any irrigation or drainage works in the farm. Now there are also some modern machines like laser leveler tractor or dual RTK, real-time kinematic GPS drainage plow. They based upon a technology called as global positioning system. So this global positioning system is using a platform called as GNSS, which is Global Navigation Satellite Systems. And nowadays, a real-time kinematic workflow is available from this platform. And it is a very fast data reception. Because of that, now it is possible to calculate the levels in real time. So earlier, the data was not real time, but now it is real time because the reception is very, very fast. So you can see this is a laser level tractor here. So this is a transmitter which collects the satellite signals and transmit the signal to the receiver which is installed on the tractor. The receiver on the tractor, it sends the signal to this hydraulic system so that the bucket or scraper moves upward or downward depending upon whether it is a cut or fill required for leveling that field. So this is a laser level tractor which is based upon the GPS technologies, which is called as global positioning system. And this global positioning system is changing a lot. It changed a lot over the time. Also, the second technology which is based upon GPS is the dual RTK GPS drainage plow. So this drainage plow means it is actually a drainage installing machinery which collects the real-time data from the GPS network, and based upon that real-time data, it is calculating the various levels into the farm. And you can see here, this is the contour map prepared by a RTK GPS based drainage system plow. So you can see this contour map is incidentally prepared by using the real-time satellite data. And since the flow lines are always perpendicular to the contours, you must know this, that the flow lines are always perpendicular to the contour lines. So you can see the drainage system is laid. You can see these are the drainage lines that are laid by the technology which is called as RTK GPS based drainage system. So this technology has laid already where the drainage pipes should be placed. So this is how the outcome of that GPS unit, which is mounted on the tractor, and it actually collects the real-time data. It prepares the topographical surface of that farm based on it. It also establishes a contour map, which has the vertical vertical height of only 1 or 2 centimeters. So the elevation difference between these two contours is only 1 or 2 inches. So with that kind of precision, this contour map is developed by the GPS mounted on tractor, and then the drain lines are placed. So when such type of precision planning is there, generally no areas are left as wet spots or swells or ponding. You must have seen that even though the drainage system is installed, sometimes it is not, if it is not very effective, or if the drain spacing is very large, in that case, the farm during rainy season, or when there is a canal irrigation, that time the farm will show the ponding or swells formed on the surface. So when this type of precise planning is there, like the contour map, very precise contour map is available, and based upon that, when the drain lines are laid, then generally the swells or ponding will not occur, even though there is a heavy rainfall or the canal irrigation is started. So that is the benefit of this real-time GPS technology. And you can see also by using the real-time GPS technology, and also there is a vertical curve technology in this particular tractor, by which now they are laying the drain lines, and the drain lines will have that particular grade, so that the runoff or the water into the soil profile will be quickly removed from the farm. So this global positioning system is a satellite navigation system that provides location and time information using a network of almost 24 satellites. And it receives the radio signals from at least 4 satellites at a time to give you the position of a particular feature into the field. The horizontal accuracy of these GPS devices is 1 to 5 meter. But if differential GPS is used, then this accuracy can be increased up to 5 to 10 centimeters. So let us see what is a differential GPS. And this real-time kinematic dual frequency GPS, it has accuracy of 1 to 2 centimeter because it is collecting a real-time data. So this is differential GPS. You can see there are 2 stations. One station is where you are doing your survey or you are collecting the coordinates. That is the rover. It is called as rover. So rover is actually collecting the coordinates of a particular feature in the area of your interest. And there is a base station. This base station is located far away from the site of survey. So you can see this rover is collecting the geological information or the position information from the 4 satellites. Also, it is sending this information to the base station. Then the base station is also receiving the information from these 4 satellites, and it is also receiving the information from the rover. So based upon the information that is obtained from satellite and rover, the error is calculated by the base station, and then that error is removed at this base station, and the corrected reading is sent back to the rover. So that is why the accuracy of differential GPS is more than the normal GPS. Now this is the real-time kinematic GPS. Here you can see that there is a base station inside the farm itself, the farm where you are conducting a survey. In the same farm, you can install this base station. And because the base station is in the same farm, and it is again applying the same principle like differential GPS, that the rover is getting data from satellite, it is sending this data to the base station. The base station is also receiving the data from satellite. It is calculating the error in between the reading received from rover and the satellite. It is removing this error and it is sending back the corrected reading to the rover. So because the base station is very near to the rover, the accuracy of real-time kinematic type of GPS is increased to 1 to 2 centimeters. And it is very, very precise, I think. So when this real-time kinematic GPS is used by the drainage plow to lay the drain lines, you can see this is how precise the layout or the installation of drainage lines will be. So this is a surface which shows very precise, labeled, and installed drainage lines. Now let us understand more about the topographical survey. This is DSM. This term is nothing but the digital surface modeling. So this digital surface can be made available from remote sensing, GIS, and GPS technologies. It has different names. Digital elevation model, when it is generated in geographic information system by using the contour map, then it is called as digital elevation model. And when it is generated by remote sensing technique by using radar images, then it is called as the digital terrain model. So these two types of digital surface models can be generated without going into the field. So without entering the field, you can obtain these topographical maps of your farm either using GIS or remote sensing. So these are called as digital surface models. You can see the difference here. This is digital elevation model, which is prepared by using GIS. And this is digital terrain model, which takes directly the satellite data and creates the terrain. So this is more precise. The DTM is more precise than the DEM. Now from where it is possible that one can collect the contour map or one can collect the satellite imageries and prepare these DEM or DTM into GIS or into the image analysis softwares and prepare their own DTM or DEM. It is also possible. But for the people who just want to use it one time, the DEM or DTM, for them, there are the portals available, the national portals, or you can say national geo platform are available on which you can get these digital elevation models or digital terrain models. All type of geospatial data is available on these geo portals. You must have heard about a Bhuvan geo portal of Indian Remote Sensing Agency, or ISRO, Indian Space Research Organization. They have created this national geo platform called as Bhuvan, and it is a geo portal. This is the web address, you can see. And you will get 2D data, 3D data. There is an open data archive. The climatological environmental data is also available on this portal. Then thematic services. Thematic services means the maps which are prepared using GIS based upon certain themes, like suppose a soil classification map, taxonomic map, or suppose you want the water table depth map. So those thematic services are also available. Then they also give you tool to create a map in GIS by using the different available layers on this geo portal. So you can see this is the, I was telling you about the digital elevation model and digital terrain model. So this is the digital terrain model of the entire country, which is available on Bhuvan. You can select the area of your interest by giving longitude, latitude, or simply by giving the location, name of the location, and it will give you the 3D map or the digital terrain map of your area. By using that, you can again analyze it for having the contour lines on it and then use it for planning the drainage system. This is the Bhuvan's 2D data, and it is in the form of maps. So you can see this is a hydrological data that is available on Bhuvan. So you can see the drainage network of the entire country is available here. So if you want to know which river is passing by your farm and you want to take the water of your drainage system to that particular rivulet, then that rivulet will also be seen here on this map, hydrological map. So you can see here, you can also have a satellite maps, hybrid maps, terrain maps. So these type of 2D maps are available on the Bhuvan platform. Then there is also one more geo portal or geo platform available, and it is from the National Bureau of Soil Science and Land Use. So this agency, which is located in Nagpur, it has provided this Bhumi portal, on which also you will get a lot of information that is very, very useful for planning the drainage system. It gives you all geomorphological and topographical information about any area in our country. So this Bhumi Geo portal is also very, very useful. For example, I derived this map this morning about the salt affected and waterlogged area for Maharashtra by using the Bhuvan app or Bhuvan Geo portal. So if you put the name of state or the location of the village where you want to work and just ask the theme, like I want to know the salt affected area in this particular region, then it will give you this type of very well drawn map, which you can use even in reports or for presentation. So this facility is available. So one doesn't need to purchase a GIS software or remote sensing software to collect, to just have the data, to just see the data. But if you want to analyze the data for a certain modeling or for a decision support system, then you will need to have your own softwares. But as far as just for planning purpose, if you want to use this type of data, they are available on various national portals. So you can just get this data from those portals. Now, as I told you, remote sensing through satellites, many of you must have come across during your work or during your education. But remote sensing through the drones, you must have seen drones carrying the camera in weddings or in some programs, government programs, mapping or taking the photographs of the people and the wedding ceremony. But drones are also used for a survey, and these drones not only just carry the camera, but they have softwares loaded on them so that they give you the real-time information. So let us see one example of the drone surveyor here. And it has a post-processing kinematic workflow software installed on it. And it uses this software while flying and mapping the land surface. So you can see here, this drone, when it flies, it assumes one air point as the base point. Whenever we conduct any survey, we are supposed to fix the benchmark, right? Just like that, this drone also needs to consider one base point, and it can consider this base point as an aero point, the point that is available in the air. And by considering it as a benchmark, it calculates the relative levels into the entire area. So by taking the flight and considering the base point, it is able to calculate the topographical surface of that particular area. Now, what are the advantages of using drones for survey? It is very easy to operate. It comes with its own data processing platform. So earlier, when we were looking at the topo sheet, Survey of India topo sheet, we were supposed to collect that contour data from the topo sheet and then put it into the GIS software or put it into some statistical software for generating the topographical maps. But here you do not need to use any cumbersome or difficult software like remote sensing analysis software or GIS software. This data processing platform is available with the drone itself. So you just have to take the drone's data, or the platform will just pick up the data from the drone and it will give you the output. So since the base data or base point that is considered is an aero point, the data gathering and processing is also very, very fast with the help of drones. The post-processing kinematic workflow technology of the drone gives it a status more than a carrier for the camera. The drone take and record precise positional data from the air through aero points. And this cuts the need for more ground control points. Otherwise, if you just go for a normal drone survey, you will see that a lot of ground control points are needed. Even when we are using satellite remote sensing or satellite imagery for analysis, we are supposed to go into the field and collect the ground truth. A lot of ground control points we are supposed to collect, and then those that information we feed into the software, and then we are able to analyze the satellite imagery. So since the drone considers the aero points, we don't need to actually hike or walk into the farm to select the ground control points. So it gives accuracy of 1/10 of a foot. So that much accuracy can be achieved. And after the flight is been flown by the drone, the process is the simple data upload to a post-processing software. So that's why these drone surveys are much easier than actually using any other technology like remote sensing and GIS. So GPS and drones, these are the two technologies which are really coming very fast with a lot of innovations and are accepted very well even in machine language or big data or artificial intelligence. So this is a hyper-realistic 3D model that is generated by the drone surveyor. Here, every point is georeferenced. Also, the volume measurement and cut fill calculations are possible by using this surface. So drones can generate this type of very hyper-realistic. The meaning is that it is very high resolution data. It is almost the real data 3D model, which is used for calculating the volumes, cut fill, or the slopes. So that's why it is very precise for planning the systems like irrigation and drainage. The drone surveyor, after processing the data, can also generate this digital surface model or digital elevation model. And it depicts the elevation data for all the features, both natural and artificial, that were captured during a drone flight. So after having a drone flight, you will very easily get the digital elevation model. Also, the drone surveyor provides you with 3D wireframe survey model. So the area which is surveyed, it can be converted into a 3D image of that particular area, and it allows you to measure the depth of the feature, the elevation of the feature, the geometry, whether it is rectangular or circular, and the location in space. All these data is available here from the 3D wireframe survey model. It also provides you with the 2D orthomap. Orthomap is a 2D map on which it is possible to measure the horizontal distances between 2 points. So the data that is required for planning a drainage system, all topographical data, whether it is the desired slope of a main line or desired slope of a lateral, desired slope of a collector drain, whether it is the topographical analysis of your farm or the areas adjoining to your farm, everything is available through the drone surveyor. Now I explain you how GIS and remote sensing they work, but based upon the same technology, the GIS analysis technology, some tools are made available by different companies for design of drainage. And I have enlisted the tools here. I'm not promoting these tools, but these are the most effective tools because they use comprehensive data and almost they solve the entire purpose of designing a drainage system. There are so many tools available online, but they only do the drainage design partially, or they are not very effective. So I have not enlisted those, but these are the tools which are very, very effective, like WM Drain. WM Topo, FarmWorks. These are the tools that are developed by Garmin, which is very specialized in GPS, in selling GPS, or it is a GPS producing company. So Garmin has developed this. So similar companies have developed these softwares: Landrain, Lee Contour, Land Improve, Discover, SMS, AGPS Pipe Pro. AGPS Pipe Pro comes with one more technology, which is called as vertical curve technology. It helps in laying the drain pipes with a proper grade, and also it helps that the cost of the system should not increase. So it's very useful software, AGPS Pipe Pro. Then there are some calculators made available by this LNI's drainage guide. So those are simple calculators if you just want to calculate the drainage coefficient or some grade of the main line. So these calculators are very handy. Then this CAD software is also used for designing the drainage system. So these tools that are enlisted here, they not only collect the survey data, but analyze it, the design, installation, and verification after installation. All these 5 tasks are done by these technologies. This WM drain technology, it is used on drone platform. AGPS Pipe Pro is used on the drainage installation machineries. The Landrain, Lee Contour, Land Improve, Discover, these are used on the drone platform. This SMS is working like a GIS software. These calculators of Illinois drainage, they are like GIS calculators. CAD is also a software. But AGS Pipe Pro, it can be mounted on a tractor, or it can be mounted on a drainage installation machinery. So on different platforms, these tools are mounted and they are used for the drainage system design, its installation, and after installation, even the maintenance. Now, some institutions, they have developed decision support system for various purposes in agriculture. It could be a decision support system for distributing the canal water to different regions which come into the command area of a dam, or it could be a decision support system for deciding which crop should be sown into particular area or particular agroclimatic region. So this type of decision support system can also be developed for managing and maintaining the drainage system, because once the drainage system is installed, after that also you need to manage and maintain the drainage system in a proper way so that its performance will remain over a long time. So you can see here, this is a decision support system for this particular drainage system, which is installed here. You can see the drain lines. So this is the outlet, which is just near the ditch. So you can see it is 13 centimeter below than the position of the main line. So this type of maps or profiles will be available to you from that digital or from the decision support system. So this type of geographical information about your area or topographical information about your area will also can also be stored by developing a decision support system for that particular drainage system. For example, we have planned one session in this training program about the community drainage project in Shirol, which is in Sangli district. So that community drainage project, which is covering some hundreds of hectares of land, they can have this type of decision support system. It is very essential for these large scale drainage systems to develop their own decision support system, because the changing climate is challenging many design parameters that are already there. So you can see that in this decision support system, they have created these zones of influence. So it is just an analytical procedure they have followed. So they have considered that suppose the outlet has elevation of this much, then what will be the influencing zone? So when the water level at the outlet, you want to vary it. For example, when we want to do a controlled drainage, sub-irrigation, in that case, the water level into the ditches are required to be controlled. And during that controlled drainage operation, what will be the influence on the crop in the farm? Those influence zones are delineated by using this decision support system. So the red shows already that the crop is suffering in this zone. So if you keep the water level to that particular depth, then there will be ponding in this area and the crop yield will suffer. So beforehand, you have this information so that you can make the proper changes to keep the sustainable crop yield of your farm. So this is how the geospatial technologies are used: the global positioning system, the GIS, the remote sensing, the drone surveyor, the real-time kinematic workflow. So all these things, new things are coming into into agriculture, and all these things are very, very useful in precision drainage system management. So if all these technologies are used, then the drainage system will become a precision drainage system. So this is all about today's presentation. And if you have any questions, I'd like to answer. Dr. Darvi?
Hello.
Yes.
Hello, madam.
Yes, if there are any questions from the participants.
Hello. Participants can drop their queries in the chat box. Okay. Ma'am, first question is, what are some examples of geospatial technology tools? Hello?
Okay. As I told you, the decision support system, it can be used as a tool. It is based upon geospatial softwares like remote sensing and GIS, but it can be used as a tool for taking decision about the drainage system. That if the drainage coefficient is changed from this to this, what will be the effect on the crop yield? Okay, that type of decisions can be obtained from the decision support system. So decision support system is one of the geospatial tool, you can say. Also, there are examples of real-time geospatial data that is available. It can be used as a tool. So real-time geospatial data, it is analyzed, and the decisions are taken based upon that real-time analysis. For example, it is used mostly in disaster management. So geospatial tools are also very useful when it comes to managing the disasters.
Thank you, ma'am. Next question is, what are the applications of remote sensing in drainage?
Remote sensing has many applications. I only explain today about only the topographical data. But remote sensing can also be used in detecting the salinized area or detecting the deteriorating crop yield into that particular area. So remote sensing gives you one plant index, which is called as normalized difference vegetation index. So based upon this NDVI value, you can assess whether your crop is healthy or it is suffering due to waterlogging. So based upon the mapping that is done by the satellite remote sensing, you get the imageries, and from these imageries you can identify which areas in your farm are suffering, or sometimes visibly you can see the waterlogged area. If the water is on the surface of your farm, then visibly you can see that there is a waterlogged area. And when this remote sensing data is fed into geographical information system, you will be able to actually analyze and calculate how much area is suffering due to salinity and waterlogging. Also, for mapping the features on your farm, for example, the drainage network is very important when it comes to installing a drainage system. You need to put all the water that is coming out of your drainage system into the natural drainage network, and it should flow away from the farms of other people. Otherwise, there will be a conflict. So for finding where you are located in that terrain, for that purpose also you can use remote sensing technology. Remote sensing data is also used for modeling. If you want to model the crop yield in different salinity levels of the soil, then that modeling can also be done by using the NDVI values that are obtained through remote sensing. You want to know only about remote sensing, right? So,
okay, thank you, ma'am.
These are the
next question is, can we distinguish saline soil and sodic soil from the remote sensing technique?
Yes, we can, but for that purpose, we need to collect a lot of ground truth data. So the ground truth data should be, means if you want to just know what is the soil type, then the ground truth data required is little bit less. But when you talk about the salts and when you talk about the sodicity, then it is the ground truth data will decide that how you will identify these areas. So ground truthing is very important, which is, of course, you will have to collect the samples, analyze those samples, calculate the level of salinity in those samples, calculate the level of sodicity, and then depending upon several iterations, then it will be able to point out which areas are sodic and which areas are saline. Again, you will have to verify by going on ground that whatever it has calculated, whether it is accurate or not, you will have to calculate the accuracy. So after doing that, you will be able to find the areas. But it is going to be very, very tedious as compared to any crop map or soil map, because it is actually mapping the chemical nature of the soil.
Thank you, ma'am.
Certainly the reflectance of saline soils is different than the reflectance of the sodic soils. But sometimes if there is a salt sprayed on the sodic soil, then it will not be able to distinguish. So it depends.
Thank you, ma'am. Next question is, DEM is not part of remote sensing. Why?
DEM?
DEM, digital elevation model, is not part of remote sensing.
Remote sensing actually gives you the imagery, and it gives you mostly the coordinates of the feature. It does not give you the elevation data. That is the problem. It gives the georefer data, but it does not give you the elevation data unless it is a radar data. So there are special platforms like LIDAR. You must have heard about LIDAR. Then SRTM. So these are the special radar satellites which throw light on the features. So the light is thrown on a feature, then on the other side of the feature, a shadow is generated. And based upon the features of that shadow, or based upon the dimensions of that shadow, the height of that particular feature is calculated. So the elevation data you will not get from the false color composite imagery of remote sensing or the panchromatic imagery of remote sensing. You will get this elevation data only from the radar imagery. Okay, there are different 2, 3, 5 platforms are available for radar imagery. and you get this data free of cost. So these platforms also have GeoPortal, so you can go to this portal and download the data. And only that radar data is used for generating the digital surface model. And this digital surface model is called as digital terrain model. These are synonymous terms. Digital terrain and digital elevation, they are not much different. Elevation also indicates the height of the feature. The terrain also indicates the height of the feature from the benchmark. So both are synonymous, but DTM is used especially for the elevation model or the surface model that is generated by the radar data of remote sensing. And elevation model is generally referred for the map that is generated in GIS by using the contour data from the Survey of India's topo sheet, or through the physical survey that you have conducted, or the GPS data that you may have collected from the farm. So when that data is analyzed into GIS and a surface model is prepared for an area, then it is called a digital elevation model. But these terms are synonymous: digital surface model, digital terrain model, digital elevation model. They give you the same thing. Digital terrain model is more precise as compared to digital elevation model, because when we generate the digital elevation model in GIS, we use the statistical techniques, right? Means when interpolation is done, and suppose in between these 2 points, there is some elevation difference, it will not be counted by the statistical interpolation methods like kriging or isometric interpolation methods. It will just calculate it as an average. But when a radar data collects the data, it is very, very precise, because it is the actual data that comes from the Earth's terrain. So actually the features are mapped, and the height of those features is measured by the radar data. So it is more precise than the digital elevation model.
Thank you, madam. Next question is, what is the resolution of image required for design of drainage system?
Where you want to apply this imagery data, it depends on that. If you want to do the yield modeling in your farm, then the resolution of Indian remote sensing satellites, the false color composite, has a resolution of 23 meter by 23 meter. That is enough. So you can use it for yield modeling, right? But if you go to MODIS data, MODIS is a Chinese satellite, and it has a resolution of 100 meter by 100 kilometer by 100 kilometer. So you cannot use that data for planning your drainage system. So most of the Indian remote sensing satellite data is very, very suitable for using it for planning and designing the drainage system. The panchromatic data, which is generally used for mapping drainage network, it has a resolution of only 1 meter. So any object of 1 meter will be seen into that imagery. And any object of 23 meter by 23 meter dimension will be seen into the false color composite. So that is the meaning of the precision, or that is the meaning of the accuracy. So any object which is less than 23 by 23 meter, it will not be seen in false color composite. Okay, that is the meaning of resolution. So mostly the Indian remote sensing satellite data is suitable for using for planning and managing the land drainage systems.
Thank you, madam. Next question is, how remote sensing geospatial technology helpful in deciding the slope for drainage and salt management?
Okay, remote sensing is not used for this purpose, but GIS is used. Geographic Information System has 2 modules embedded in it. One is a spatial analyst and one is a 3D analyst. So you will have to develop a model, okay, based upon the soil water balance. You must know about soil water balance. So a model based upon the soil and salt water balance has to be developed in GIS environment, and then GIS will be able to calculate, as you said, the slope or the salts that are drained, by using these two modules, that is spatial analyst and 3D analyst. Remote sensing cannot do this. It can provide you the information like what type of crop is there, what type of land cover is there. So that basic data which is required for the model, to run the model, that can be obtained from remote sensing, but remote sensing directly cannot give you the slope or the leaching of soils.
Thank you. Next question is, in case of rural areas where internet access is a challenge, how would you use this tool effectively and efficiently?
Okay, internet is a challenge. Yeah, that thing has to be considered when it comes to smartphones also, but people are using, right? In rural areas, people are using smartphones. But the GPS technology mounted on tractors or mounted on the drainage plow, they are actually using that network of 24 satellites. So this is available everywhere you go, unless it is a very, very remote place, like some forest in Alaska, or some, you can say, some place on Earth's polar region. Otherwise, those 32 satellites are always available, and even a lot of vehicles are using GPS technologies nowadays. So the same GPS technology is used by the tractors or the drainage plow that are used by different contractors or companies. They are using the same GPS technologies. So it is a satellite constellation of 32 satellites, and it is not based upon internet. Actually, it actually collects the signals. GPS has a receiver which is not based upon some internet. It collects the data directly from the satellites. And in rural areas also, people are using smartphone to find the routes, or for going from one place to another place for tracking. So,
thank you, ma'am. Can we find the exact location of waterlogged area of a part of a district through online platform?
Yeah, means the geo portals that I was telling you about, Bhuvan and Bhumi, isn't it?
Yes,
is it the same question?
What are the...
I'll advise you to visit these websites of Bhuvan and Bhumi and explore yourself, because lot of possibilities are there. Lot of things they have given on these platforms. So you can just go and explore on these websites whether the data is available for the area that you are designing.
Okay, ma'am. Thank you. RTK drainage system, any application in India, please give reference.
Actually, many companies, there is one lecture we have kept for you on installation of drainage system. Which company is that, Dr. Darvi? It's
Rex, ma'am. And Indian is Astral Pipes, Polypipes.
Yeah. So probably they will show you how they are using these technologies in field for installing the drainage system. Because installing drainage pipe inside the soil profile is a very tedious task, and if something goes wrong, they will be spending a lot of money for removing the drain pipe again and then placing it again. So they are the first people to bring these technologies from abroad to our country, because that saves a lot of efforts and a lot of cost for them. So when that session is there, you should attend that session, and they will certainly show you. The may not be the RTK one, but the GPS based, the laser leveler, those techniques they will show you. The RTK based, I'm not sure whether it is used in nearby areas, but let us see what they show you.
Thank you, ma'am. I think most of the queries it's solved by you. So I am very much thankful to you for such a nice and informative presentation about this advanced technology in agriculture. And I am also thankful to all the participants who listen patiently and for their cooperation. I am very much thankful to all the participants. Now tomorrow our lecture will be on control drainage, a new approach to the managing nutrient loss from subsurface drainage system in Indian soils. And our eminent speaker is Dr. A.V. Karegowda, scientist at AICRP, Gangavati, US, Raisur, Karnataka. So I requested all the participants to be joined on the time. We will share link for this lecture 20 minutes before. Thank you all. And the quiz for these 2 sessions, we will provide the link in the evening. So please submit your responses within time. Thank you. With the permission of the organizer, I am ending the session here. Thank you all.
Thank you all.